first section of the acidic environment was about using indicators, and this section leads into dealing with acid rain. It's chapter 7 in your textbooks. Okay, now when you burn a substance in oxygen, then it will form an oxide. So if you start out with something which is non-metallic, such as sulfur, yellow sulfur, and you burn it in oxygen or in air, which is 1/5 oxygen, then you end up with sulfur dioxide, and that's that white powdery vapor up here. And some of these are pretty good at dissolving in water, but that's not just pure water. That's, of course, universal indicator with water. And that's how we know that we've made an acid down here, because it's the universal indicator's turned red. Sulfurous acid is not red. It's just that you happen to have the indicator already in the water. And it is sulfurous acid because it's H2SO3, not SO4. Okay, now if you start out with a metal like magnesium and you burn it in oxygen, there's that incredibly bright white light flame. And that powder there is the magnesium oxide, and it falls into the water. But the problem is it's not very soluble. I mean, if you look at the solubility rules, it tells us that metal oxides are insoluble except group 1 and the lower half of group 2. Well, magnesium is just outside of that. So very little magnesium oxide actually dissolves to form the alkaline solution. But when it does, it'll form the magnesium hydroxide. So when we're talking about bases, that term there, bases, we generally include things like ammonia, but apart from that, we also have metal oxides and hydroxides. So it's not just sodium hydroxide, but it would also be things like magnesium oxide. And they're referred to as bases. So it's not only the hydroxides or alkalis, it is also the basic oxides that don't dissolve. They all count as bases because they all react with acids. And that's the point. When you get to a neutralization reaction, we tend to say that it's an acid plus a base makes salt plus water. But included in that are basic oxides as well. They will also give us salt and water. And an acidic oxide reacted with a base will also give us salt and water. So it's pretty much, any of those combinations are going to give you salt and water. The neutralization reactions, although we deal a lot with acids and bases, there are lots of reactions that are not neutralization. Many redox reactions are not neutralization reactions. And a lot of organic reactions aren't neutralizations either. So, you tend to get into the idea of thinking that everything's a neutralization reaction when it's not. But an acid and a base make salt plus water is your standard neutralization statement. Now, in a salt, you have an anion and a cation. Well, the cation is the positive ion. And most of the time, we're talking about a metal that's come out of the base. And we name the metal first. And then in the salt, we name the non-metal or non-metal group that's come out of the acid. But we don't name it. We have to change the ending of the name. Ik becomes ide or ate. Now, hydrochloric acid just becomes something chloride, like sodium chloride or potassium chloride or magnesium chloride or whatever else. It's when you have things like nitrous acid, which is HNO2, and nitric acid, which is HNO3, that you're going to be very careful of the ending, because one single little letter there makes this nitrate and this one nitrite. So this one is the ite is the one with the lesser amount of oxygen in it whenever you're trying to name these things. So we've come across these types of oxides, and there are acidic oxides and there are basic oxides. And the more non-metallic a substance is, the more acidic the oxide it forms is. And the more metallic a substance is, the more basic the oxide is. And then you've got some oxides that are not acids or bases, and you've got some that are actually a bit like both, or will react with both. And often they're very insoluble, so the only way to know if they're acidic or basic is to put them into a reaction and see if they are actually dissolved by the acid or dissolved by the base. And then you can say whether or not it reacts with it, and if it reacts with it, then it's amphoteric. And that's a little YouTube that I'll be showing you very shortly that relates to that. And now, so this is the aluminium oxide. That's one of the really good examples to remember of an amphoteric oxide. It's a fairly easy reaction to learn. I mean, this is aluminium oxide. It's a 3+, that's 2-, and that becomes Al2O3. And there it is with hydrochloric acid. Now, when you put them together, these hydrogens here in the hydrochloric acid react with these oxygens here, and they go off and make water, which is exactly what you would expect in a neutralization reaction. And the aluminium is left over with the chloride, which makes the aluminium chloride salt. Standard neutralization reaction. But as well as that, aluminium is also quite capable of being dissolved by a solution of sodium hydroxide and will form a kind of complex ion. So the aluminium actually forms, which is 3+, reacts with 4 OH minuses. So 3+ minus 4 is -1. So all of this part forms a complex ion with a charge of -1. And that has a +1 charge. And this is called sodium aluminate. Now, it actually initially forms this, and this is the one I always remember, but after a while, it loses, this part here decomposes into water and leaves some oxygen behind. So I tend to learn this one because it makes sense to me. But this one is just as equally valid if you really want to learn that one off by heart. That's fine. But you need to know at least 1 or 2 good examples. And aluminium oxide is a good example. Another good example is zinc oxide. Lead oxide's another one. And when you look at the periodic table and where they are, here are your metallic oxides. And the more you are towards this side, the more metallic or basic the oxide is. And then over here are your non-metallic oxides, and the more acidic they are when you get over this way. And then in between here, these are the ones that form the amphoteric oxides. And it's a bit like having the metals, the non-metals, and the metalloids, but it's not quite the same because there are a few slight differences in there. So if you have a look at there's hydrogen, beryllium, and then if you push out this middle part and put that back into there, you would see it kind of just steps down into this lot over here. All right, but the easy ones to remember are the zinc, the aluminium, and the lead. So I would choose 2 of those and learn them. The other thing is there are these neutral oxides, like carbon monoxide is neutral. N2O is neutral, but NO2 is not. NO2 is acidic. And you know that because when you put it in water, it ends up turning litmus red. So that's how you know it's acidic. And the other one's neutral because it doesn't. And then, of course, oxygen doesn't turn water acidic, so that's fine. Okay, then, ladies, I think we're pretty much past the point where you just need to know a few of the ones that are amphoteric, and you're ready to do a Kahoot, I think.